Graphing polynomial functions, identifying zeros, and showing end behavior. Does anybody remember what zeros are? The zeros of a graph or the zeros of a function. What are the zeros? The solutions are zeros. Where do they show up on the graph? They're x-intercepts, right? Zeros are x-intercepts. So we're reviewing that today. So here's your bell work. There's one more, so there's 3 total. We'll do 3 bell work questions. Then we're going to do 4 word problems to review what we were covering before. And then you guys can start your assignment. Does anybody else need to turn their phone in? Let yourself get bored. You don't have to be staring at something, doing something, multitasking your brain. Let your mind wander. Maybe you'll think about graphs. Give your brain a rest. It's a what? Ava, what's the leading coefficient in number 1? -4. The leading coefficient being the number in front. LC, leading coefficient, -4, the number in front. Next group. Degree. Nathan or Brian, do you guys remember what the degree is? The exponent. So the degree of this one is 3. It's a cubic function. 3rd degree polynomial. So I would say that this is odd with a negative leading coefficient. So I'm picturing a graph like this. 4. Which one is an odd negative leading coefficient? The left or the right? Just call it out. Right. This one's negative and it's odd. It's negative because it's going down. It's odd because the ends are opposite, right? All of that is important for today's problem. So I can already picture this graph as starting high and ending low. Number 2, evaluating functions. We need to find p of 3 and p of -5. So that just means plugging in. So for 3, I'm going to put a 3 in where x is. And for -5, I'll put a -5 where x is. So 2 different problems. So I'm going to give you guys time to calculate those. You can compare answers in your group. Feel free. Your exponent. These are on the back counter and they're unclaimed. So if you lost a notebook, claim it. I'm going to start using it for paper. If you think one of these might be yours, just come check it out. guys compare your answers with the people in your group. Nobody has an answer for 3 yet? No, funny numbers. What did you get when you plugged in? Okay. See the right answers? So 3 times 3 times 3 is 27. So you may have put 9, kind of a simple error here. 3 to the third is 27. 27, take away 30. And you should have got negative 43. So I would say P of 3 is negative 43. The reason this is coming up here, we're talking about graphs, is that this is actually an ordered pair on the graph of this function. I have a point where x is 3 and y is negative 43. So that's going to help me create a graph, plugging in numbers and getting y values out. Negative 125 plus 50 minus 40. Negative 115. So I have another ordered pair on this graph at negative 5, negative 115. Questions on those two? All right, last thing for Valbert. And then after this, we're just going to do 4 word problems. Rate this note. We talked about this briefly before we started studying for your midterm exam. It doesn't make a whole lot of sense until you get a chance to really use it. The maximum number of turning points of a polynomial is always 1 less than the degree of the function. What the heck are we talking about? Maximum turning points of a polynomial is always 1 less than the degree of the function. Okay, so for example, x to the 4th can have at most 3 turning points. So I'm going to draw 2 even degree polynomials, and you tell me which graph could be x to the 4th, A or B. Positive and even degree. So it's going to start high and end high. It's a positive even degree. All right, is that x to the 4th? Or is this x to the 4th? Yeah. So this one could be x to the 4th because it has 3 turning points. 1, 2, 3. These are the turning points it's referring to. This one has 1, 2, 3, 4, 5. So this one has to be at least x to the 6th to create that many turns.
So right here it says it's always 1 less, but right there it says at most 3. So does that mean it can be 2 and it can still be x to the 4?
So instead of at most, this says the maximum number.
That says that? It says always 1 less than the degree.
The maximum number.
Oh, okay. Oh, yeah.
So I think they mean the same thing.
Yeah.
This is official, and that's what I just wrote. So if you want to go off these words.
I shouldn't read that. Yeah.
No, it was the words. Okay. Other good questions? Okay, let's do some word problems with graphs. We have 4 problems to do. Here's number 1. I want you guys to read it, discuss it in your groups, try to figure out what it's asking you. I'm going to give you guys time to work on it before I say anything. It's actually talking about a video game. It says Jalen uses a 4th-degree polynomial to describe the shape of 2 hills in the background of a video game. Pixar. There's a cool video about Pixar using polynomials to create characters and shapes. There really is polynomials in the backgrounds of all of our digital work. What video game did those hills look like? Anybody? Pac-Man? Okay, maybe. Pac-Man doesn't have hills. Like the arcade game? No, there's no hills in Pac-Man. It's black. I don't know what that is. Okay. I'm thinking of Mario Brothers. But also Angry Birds. Doesn't Angry Birds have hills like that kind of? In the background. Anyway, go on. Try to figure out what the words mean. It's a lot of vocabulary. No math, it's all vocabulary. You're doing something. We'll just finish the lesson first.
I think
You guys, I'm not like doing this. We're gonna go over it. That's what you're doing the assignment right now. If you skip the classwork and always just do homework, your grade will fall. Happens all the time. This is estimate the x-coordinates at which the relative maxima and minima occur. Can anybody figure out what it means by relative maxima and minima? Isabel, what do you think? What's a maximum and a minimum? What's that? The highest and lowest, right? So we talked about maximums and minimums with quadratics. All graphs have a maximum minimum. The reason this has the word relative is because this is a minimum, but it's not the most minimum of the graph because this arrow goes down for infinity and down for infinity. That's called a relative minimum. So when I look at this graph, it has 2 maximums. This is new vocab for you. 2 relative maximum, which is a high point. All right, discuss in your groups where the high points are. Write them down. Where are the high points? It has 1 relative minimum.
It'd be right hill and then.
Okay, a relative maximum. So here's a maximum. I'm actually going to use the word between. We have a maximum between x equals 1, 2, 3, 4. X equals -3 and x equals -4. So it's funny when they're asking about a maximum, most often they're not asking for the actual y value. A lot of people hear maximum and they think they should identify this y value. Estimate the x coordinates where they occur. The x coordinate is between here and here. And that's where your maximum is. No, so you can probably listen out 5-4. Here you go. 5-4, or if you want to title it word problems, that's how I'll refer to it. We're doing 4 graph word problems. So our first maximum is between -3 and -4. Where's the second one? Let me count. There's the maximum. It's between 4 and 5. There's only one relative minimum. There's only one valley. Those are like hills, and this is like a valley. And it's at x equals 0. The minimum is 0, -3. Half students in answering this question are going to give me -3. In fact, more than that if they don't practice or read. But it's asking for the x value where that occurs. It's at x, and the actual minimum is -3. Questions on this vocab? Let's do another one. Okay. This is supposed to be the outline of Mount Rushmore. Have any of you been to Mount Rushmore? Oh, 2 people. Yeah. Okay. All right. So this has to do with the turning points definition that you wrote down, number 3. What is the smallest degree possible for the equation that goes with this graph? So in order to identify degree, figure out how many turning points there are. In order to find degree, count turning points. I'll help you. So here's a turning point. I'm going to extend this so you can see, it's definitely going up. This side is also going up. Here's a turning point. Here's a turning point. This looks a little sharp, but it should be like a smooth. All right, so I circled the turning points. You guys discussed what degree do you think it could be with that many turning points, and specifically that end behavior. Is that an even or an odd end behavior? Both arrows go up. Is that even or odd? Even. You should be thinking of an even number. What number then? It's got to be an even degree because both arrows go up. And we count 7 turning points. 1, 2, 3, 4, 5, 6, 7. 7 turning points. The smallest degree that this graph could have is 8. The polynomial that writes this graph could be an 8th degree polynomial. It could also be 10, 12, 14. It can be higher than 8, but it could not be anything lower than 8 because of the 7 turning point. Questions? Okay. Move on. All right, our last two, we're actually going to create graphs. A banker models the expected value of a company in millions of dollars by this formula. N to the third minus 3n squared. So you're going to graph the cubic function. N is the number of years in business. Sketch a graph. So I'm going to give you a clue how I want you to do this. If possible, factor. This can be factored. 2 people came up with it last period before I gave the answer. So I'm not going to give any answers until at least 2 of you can factor that. N to the third minus 3n squared, factor it. Maybe you want to look at it with x's? Factor it. Do you have any great ideas for you? Want to try to factor that? Can't factor it? You probably could. Let me factor that. Try. How do you factor it? No. No negative 18 involved. Good try though. Thanks for trying. Does anybody know any methods of factoring? You got it, Eva? All right, one person got it. Who else? You got it? No? You got it? You got it? No? One more person. You were there? What'd you write there? That's what? Yeah, greatest common factor. I'll take it. Okay, 2 people. So this has a greatest common factor. They both divide by x squared. You take an x squared out, and that's the rewritten form. You good? You guys know that? Probably didn't do much factoring over break, huh? It's okay. You'll get back into it. You'll get back into it. Like I said, you factor in every chapter of this curriculum. So this is our factored form. X squared, x minus 3. I want you to solve these factors. So when you have to graph a polynomial, if possible, factor. Step 2, solve the factors. Winter break. So when we solve factors, we set them equal to 0. So I would say x squared equals 0. X minus 3 equals 0. Solve those. Isabel, what do you get when you solve those? Okay. How do we solve x squared equals 0? Ella? Yes? Okay, yeah. Add 3 to both sides. So we have one answer. This is an x-intercept. X equals 3. All right, mark this one. Square root. Solve by square rooting. So x equals plus or minus 0. So plus and minus 0 are really the same thing. But when you square root to find an answer like this has what's called a multiplicity of 2. It means it counts for 2 zeros. So it's a third degree polynomial, and this is 1, 2, 3 zeros. This is a new word I'm telling you, multiplicity. All right, an even multiplicity causes a turning point. Take a little note on that. Okay, so we have 1, 2, 3 zeros. You'll have to draw a little graph on your paper. It only has to go left, right 5, up, down 5. Right, so we have 2 points to create this graph. All because we figured out how to factor. So let's talk end behavior. So step 3 would be figure out end behavior. Determine the end behavior. Third degree is odd. So the ends are going to go opposite. And it's positive. So it should start low and end high. All right, so even though I only have 2 points, knowing the end behavior, I can sketch a good graph here. Let's start low. I'm going to turn at the multiplicity. I'm going to hit this and turn down. Move back through this point and end high. It's a little sketch. Now I want you guys to be a little bit more precise on this. So we're going to make a table to figure out really how far down this should go. So to finalize our graph, we're going to do a little table. So step 4 would be table. You don't jump right into a table because your table could have the wrong x's in it. Setting all of this up, this factoring, the zeros, and the end behavior helps you determine what points to put in your table. So we already know we have a point at 0, 0, and another point at 3, 0. So let's plug in 1 and 2 to the function to get these 2 points more precise. So you're plugging it into x to the third minus 3x squared. Plug the 1 in, get your answer. Plug the 2 in, get your answer. And then put your points down and make your graph a little more precise. See if your points make sense. They should follow the pattern, the sketch. Okay, so now on the assignment, those points are going to be your x's. Like those 2 purple dots are this. You'll do that. And then you're going to try to move through them correctly using end behavior. Make sense? The next one I think will help. One more after this, then you're going to start your assignment. about graphing. Covered. All right, what did we get? Aubrey, did you plug in 1? What'd you get? -2. Anybody else get -2 out? Okay. So we have another ordered pair at 1, -2. And 2. JD just got 2. What'd you get? -4. Anybody else get -4 out? Okay. So now, again, to re-emphasize, we use the factors to set us up. We use end behavior to get the ends right. And then the table fills in between the factors. So I'm going to erase my purple line because I have 2 specifics. I got 1, -2, and I got 2, -4. I start low, move through the points, and end high. And that's a good positive third degree polynomial. Any questions? Okay, let's do one more. This one, you're going to sketch a graph. We're not going to make a table. This table is kind of a preview in tomorrow. And on your assignment tonight, you don't have to make tables, but you have to identify zeros and know end behavior. So Ms. Sanchez asks her students to write expressions to represent 5 consecutive integers. There they are. The product gives us this 5th degree polynomial. For what values of f of x is 0? That's saying find the zeros. So what I want you to do, it'd be great if you did it in groups, would be to factor. Factor this 5th degree polynomial. Go ahead and try it. Not all polynomials can be factored. The easiest ones can be factored. It makes it easier to create a graphic if it can factor. What do you think the first step is in factoring this? Anybody? First step in factoring. Hannah, you know? What would we do first?
Try to find the greatest coefficient.
The greatest common factor. What is it? What number do they all, or what variable do they all divide by? X. Take an X out. Take an X out. And now we have x to the 4th minus 5x squared plus 4. So here, we're going to factor that just like it's a quadratic. It's called a quadratic form. If there's an even degree here, oftentimes you can factor it like a quadratic. So we're going to factor using a quadratic form. So what I mean by that is what multiplies to 4 and adds to -5. -4, -1. -4 times -1 is +4, and -4 minus 1 is -5. So because this is 4th degree, when I go to my factored form, instead of x minus 4 and x minus 1, it's x squared. If you FOIL that out, it'll end up x to the 4th. It'll all work out. So if you have a high degree polynomial and it can factor using these quadratic methods, you just divide your degree in half. So our factored form is x squared minus 4, and x squared minus 1. So we'll set all of these equal to 0 to solve. We have one answer. We have one x-intercept. X equals 0. How do we solve this little guy, x squared minus 4? Aubrey? Square root. I'm going to add 4 over, and that's a solve by square rooting. X will be positive and negative 2. So we have a ordered pair at 2, 0 and negative 2, 0. Same thing here, you'll add 1. X squared equals 1, square root, and x is plus or minus 1. Don't forget the plus or minus sign. This is why plus and minus signs are such a big deal. Because if you forget the plus or minus, you're missing out on an entire x-intercept in your graph. Finally, you can see why those plus and minus signs have like a pretty good meaning. So I'm actually going to walk around. You're not going to get credit for participation today until one person in your group graphs these 5 points and connects them correctly using end behavior. Graph these 5 points and connect them using knowledge about end behavior. Somebody in your group has to get it. Here's some paper. Do you have your notebook?